Hey guys, Chris back here with another video. So let's go ahead and jump into this. If you're not familiar with the series, essentially what I do is I attempt to solve LeetCode problems. No guarantee that my solution will work or that the video will be successful, but I just want a video of somebody going through and solving these, so that's what I'm attempting to do here. So cool, let's jump in. Given an array A of integers, for each integer A of I, we may choose any x with negative k is less than or equal to x is less than or equal to k, and add x to A of I. After this process, we have some array B. Return the smallest possible difference between the maximum value of B and the minimum value of B. So if our array of integers is 1, k equals 0, output 0. Explanation, b is 0, 1, because you can't put anything in. Okay. Add x. So you may choose any x between negative k and k, and add x to A of I. After this process, we have some range b. Return the smallest possible difference between the maximum value of b and the minimum value of b. Explanation, b is 333 or 444. So interesting. Output is 0 because there's no difference between them. So essentially, I think what we want to do in this case is, okay, if I'm understanding the problem correctly, we have an array of a list of numbers in it, right? And with this list of numbers, we can increase each one or decrease each one by k or a number that's from negative k to k inclusive. And essentially we want to make the range as small as possible. So we don't actually need to do it for each one. What we can actually, I believe, do here is find the minimum, find the maximum, and then increase the maximum by k, decrease the maximum by k. Actually, we can just find the delta between the maximum and minimum, and then subtract 2k from it. And then if we subtract 2k from it, we'll have our answer, right? So like the maximum here would be 10, the minimum here is 0. And if we subtract 2k, that we would subtract 4, which would give us 6. And the reason that this works is we only actually care, we can always put numbers in the middle, right? So if a number's in the middle, we can always modify it so that it stays in the middle, or it becomes equal to the top and equal to the bottom. So we don't actually care about any of the middle numbers. We only care about the maximum number and the minimum number. So that seems relatively straightforward. So what I want my method to do is to iterate through the array, find the min, find the max, and then do this little equation. And if we get a number that is below 0, we just want to find the min between 0 and the number that we find. So let's go ahead and do that. So let min, actually, we'll just set min to A of 0 and let max equals A of 0. One second, let's think of the case where what happens if we have a completely empty array. So if our array is completely empty, then we're going to want to return 0. So we can have this initial setup if we just have a base case where if a.length is 0, then we can just go ahead and return 0. So, and then we can have this set up because this is always going to be true, and then we always know that a will at least be a length of 1, so we're allowed to make this initial setup. So now we just iterate through the list, right? So for I let I equals 0, I is less than a.length, and then we increment I. Simple enough. And now we're going to want to say min equals math.min, and and then we're going to want to say min and a of I. And before I forget, here since we already have 0 done here, we don't actually need to do it again. So max equals math.max, and then we'll max it between max and a of I. So then we're going to want to say let answer equals max minus min. So we already know that. But then we need our minus 2k. So minus 2 times k, right? So that will be our answer. But the thing is, if answer is less than or equal, we just do less than 0, then our answer is actually just going to be 0 because we can make them all equal to the same number. And then we can go ahead and return answer. So let's go ahead and do test code. So for that case, it worked out. Let's try the 0, 10, where k is 2. The answer to this should be 6. It is indeed. Now let's go ahead and try the answer 1, 3, 6, where k is equal to 3. And output is 0 as expected. Cool. So I believe this should work for all test cases. So now we can go ahead and submit our code. Let's see if it works. Awesome. It worked as expected. Is there any optimization that we can do to this algorithm? We could probably clean up the code to make it a little bit shorter, but as far as runtime goes, I believe this is about as optimal as we can get. We came up with this clever little solution. We iterate through everything once, so our time complexity is going to be just O of n. Time complexity O of n. Nice. And yeah, that's about it for this one. Thanks for watching.